Welcome to Equals Math, Writing IEP Goals and Objectives. I'm Karen Ross Brown from AbleNet. Let's begin. Basic steps to supporting students in Equals Math is to identify expectations, then provide access to make math instruction happen in a way that meets student needs and increases understanding so it can be applied to solving problems in school and later in the real world. This is the purpose of math. The ability to solve real-world math problems with what students know and understand to the best of their ability. Any independence and knowledge in the process of problem solving is worthwhile, as it is a measure of independence and participation in students and later young adults' own lives that they previously did not have. Solving problems, too, then becomes a part of the expectations. Often students with disabilities have little access to learning how to think about math concepts and solving problems in a meaningful way. Worksheets alone do not support opportunities to learn how to think about math, nor the participation to make math class what it can be and is in thousands of classrooms. Perhaps a case can be made for worksheets for providing for rote learning, for example, shape names or the number list from 1 to 10. However, rote learning too can be a part of a fun, interactive experience with peers playing a game, solving problems, and making a connection to the real world. Small group instruction is the place for all of those things. Writing math goals and objectives with that in mind is important. Grade level standards are written to include what we consider math concepts and skills, very specifically written to each grade level. However, process standards are there at the beginning of Common Core Essential Elements, and individual state standards documents, and apply to all grade levels. For example, reading the list on your screen, make sense of problems and persevere in solving them, reason abstractly and quantitatively, construct viable arguments, model with mathematics, etc. These have different wording, rigor, and detail, yet reflect what is contained in the NCTM process standards. The terms in purple bold font show a relationship between the two process standards connected to the structure of equals. The main source of the parts of the equals lesson structure is the NCTM process standards, which were clearly based on best practice math instruction, supported by research on how we learn, how our brains work, and how math works. In equals, these standards were adjusted so students with disabilities could utilize the strength of the methods yet achieve math knowledge to the best of their abilities. All of this affects writing IEP goals and objectives, as we need to make sure all of this is achievable, yet raise the expectations from what traditionally math class has been. Students with disabilities can and do talk about math, understand representations, make connections, problem solve, make reasonable choices to estimate or predict, and recognize when the solution makes sense. It is the access to real math instruction and meaningful participation that makes the difference. It is bringing math to students that meets them where they are, supports their needs and efforts, and moves forward from that point, taking advantage of the meaningful connections in math, choosing tools and actions to take, and feel okay to express ideas in a safe, collaborative space in any way they can. Let's begin at the beginning. Place your student based on math knowledge. I will start this process at the beginning as if the student has not yet been placed in equals. If the student has been placed already and or has been learning in equals, you do not need to repeat the assessment, placement, or choosing a lesson. Simply begin at the point of the current lesson, which we will get to in a few slides. To identify expectations, goals, and objectives, begin with placing your student into the appropriate starting place in equals by their math knowledge. If this hasn't been completed to this point, it can be completed by using equals assessment, or if you know your students, you can use the list of equals lesson objectives in the overview manual or the student tracker form. Look at the lesson order and determine where the student should be placed based on what you know about your student's math knowledge. Look for the overview manual in the members only content. These are the two documents I just referenced for placing your students. The document on the left is the student tracker form, and the one on the right is the overview manual. Student tracker form can be found in members only content, first by going to equals assessment folder and then equals informal assessments folder. The overview manual is found in the equals resources folder in members only content as well. Next, read the lesson objectives included in the chapter. Look at the chapter and read the lesson objectives from section A forward. Make a decision to start at the beginning of the chapter or determine another starting point within the chapter. Sometimes this decision is made as a compromise in order to create a group of students with similar math knowledge. Next, review students' present level and consider amount of lessons that will be taught in 1 year. And this is the point you would start if your student has already been placed in equals and is currently learning math with an equals lesson. Review the student's current equals math lesson or the lesson chosen for student placement. Using the pacing guide from the equals overview manual and or your experience teaching equals math to the student, estimate the number of days it would take to complete one lesson, let's say about 10 days. Identify the number of days in the school year, which works out to be the same amount of time from IEP to IEP. Let's use an example of 180 days. Divide the total amount of school days in the IEP year by the amount of days it would take to complete a lesson. Using the example, divide 180 school days by 10 days to complete a lesson, which is 18 lessons. Taking into account short school weeks and possible other interruptions such as snow days, tornadoes, special programs, field trips, etc., reduce the amount of lessons by about 5 lessons, which leaves us with 13. So in this example, it's reasonable to expect the student would complete 13 lessons within an IEP year. This will vary, of course, depending on the amount of days it takes each student group to complete a lesson on average. Next, identify a specific skill to be targeted for the IEP goal and locate lesson objectives to support that goal. Count 13 lessons from the current lesson and look for a likely goal that includes multiple skills taught in lessons prior to the goal, which will act as objectives. There can be other lessons that appear between the lesson objectives and the goal, but remember, you will be teaching all of the lessons, not just the ones chosen for the IEP goals and objectives. As you see these examples, you will note that the criteria for accomplishing the goal and the lesson objective has been left out of the examples, as this is a decision that needs to be left up to the teacher, specifically for the student. In this example, we will cover identifying an IEP goal and objectives by first choosing a skill or concept the student will work on within the amount of lessons that can be reasonably completed by the time the new IEP is due, which in our example was 13 lessons. This student is a 3rd grader who uses materials at level 2 and does well in a group that takes about a week to a week and a half to complete a lesson. He is familiar with working in a small group setting. He can count to 10 with correspondence and rote count to 12. He can match and duplicate a simple AB pattern. Based on his assessment, he was placed in Chapter 3, and his current lesson is within Section C. The current lesson for the student is 3C7. Locate numerals 1 to 10 on a number line using the words before, after, and between to describe the location. This student typically gets through a lesson in about 7 days. Starting at 3C7 means there are 25 lessons left in the chapter. Moving at a 7-day pace, the student should complete the chapter in 175 days, which is about 5 days before 180 school days are up. Seeing that my student already can rote count to 12 and count with correspondence to 10, and he'll be working on developing number sense for amounts 11 to 20 towards the end of this chapter, I decided to focus on number sense skills by writing this goal. Student will demonstrate number sense with numerals and amounts 11 to 20. In this case, I chose the section F heading for my IEP goal rather than one of the lesson objectives. This made sense as there are multiple lesson objectives in section F that are related, in this case, to number sense from 11 to 20. I know that lessons 3C7, locate numerals 1 to 10 on the number line using before, after, and between, is a skill that will support the student when he's working on demonstrating number sense 11 to 20. The new lessons will build on his current understanding of number sense 1 to 10 and later connect that knowledge to the larger amounts of 11 to 20. My first IEP objective is from lesson 3D8, which is identify number of $1 bills equal to $5 and $10 bills. This skill reinforces the connection of constructing equal sets of 5 and 10, correspondence, and counting to 10 that will directly relate to larger amounts, particularly when working with parts and whole later in the chapter in section F. In section F, the lessons directly relate and build to the goal, as well as connect to past lessons in section C, giving us a clear view of the lesson order, creating a clear link from smaller amounts to larger amounts. Notice chosen IEP objectives 2, 3, and 4 are taken from lesson objectives 3F1, 3F4, 3F5, and 3F7 from that section, and they are combined into these IEP objectives. Count 1 to 20, identify sets 11 to 20, and construct sets 11 to 20 and write the numerals. The final IEP objective is from lesson 3F8. Student will compose and decompose amounts 11 to 20 and describe parts and whole. It is important to note I can use the equals lesson objectives as written or can combine them to write IEP objectives. Also note that I did not write an objective for every lesson, but rather found commonalities and identified benchmarks leading to the goal. Student will demonstrate number sense with numerals and amounts 11 to 20. All lessons will be taught in order from 3C7 to 3F9, regardless of whether or not those lesson objectives are written as IEP objectives. The order of lessons taught must remain intact, knowing the lessons were ordered in a way to maintain a logical order of prerequisite skills and or link to cross-content lessons. Looking at the range of skills in the lesson objectives that will be completed in this IEP year for the student, I decided that I would like to write a second math goal within the measurement content area. With 3C7 as the current lesson, I can look at section D. I see there's some very important skills I would like to include in the IEP. I wrote a goal on comparing weights and weighing objects in pounds. The first objective to support this goal is 3C8. State one more and one less than a given number 1 through 10. This is a great cross-content area connection and an important skill when reading numbers on the scale. This lesson helps create a connection to the numbers on a number line and the numbers ordered on a scale. The last 3 objectives I choose are 3D3, 3D4, and 3D5. Identify and compare sets that are equal, more, and less weight, compare weights and describe as heavier and lighter, and weigh objects in pounds. The goal is a combination of 3 of the lesson objectives. Student will compare weight and weigh objects in pounds. As you can see, all of the objectives contribute to the completion of the goal. Section E focuses on geometry, and that was left off the IEP, but that does not diminish its importance. Those lessons will still be taught as all the rest in the order given from section A to section F. Case in point, a teacher reported to us that her student spent time in his home identifying the vertex of each angle that he located in his house by naming them with the correct term on his own. This was not a homework assignment. He was proud of what he knew and generalized the terminology to another setting. We don't know which parts of math will particularly interest a student or show what they can do unless they have an opportunity to do so. All of the math content areas and lessons are important as they link to each other and provide generalization opportunities as well. Here is another example. This student has been placed in Chapter 1 and requires Level 1 support. She is a first grader who has had very little math instruction and has not been in a small group prior to this year. She struggles with maintaining her attention and is able to press a switch to turn on a toy after it has been modeled. Based on her assessment, she is placed in Chapter 1, Section A. We will look at 3 different ways to choose an IEP goal and objectives. In this first attempt, I set up high expectations. I plan to begin in Section A with lesson objectives 1A1, 1A2, and 1A3 as my first IEP objectives. I continue to teach 8 more lessons and end up in Section B with 2 more lesson objectives for IEP objectives, and now I have an identified goal. I combined all of that and wrote student will use manipulatives to explore, line up, and sort. The 5 IEP objectives match the circled lesson objectives in sections A and B. This means the student is starting with attending to math instruction and use of math manipulatives, which are IEP objectives. The student continues with lessons and patterns in the student's world and beginning measurement skills that also connect to the student. From there, the student goes on to section B with beginning matching and sorting, which are also IEP objectives. That's one option. Let's consider others. In this example, I narrow my expectations a bit and write an IEP goal and objectives closer to the student's placement at the start of Chapter 1. IEP objectives include lesson objectives 1A1 to 1A4, which cover beginning attention and engagement with materials. Lesson objective 1A5 adds more exploration using cause and effect toys and other items. It's not an identified IEP objective, but it is still taught, still relevant. Finally, IEP objective 5 is lesson 1A6, using instruments to make sound patterns. The objectives focus on beginning active participation in a variety of ways, which will help identify what the student likes. These feel play-based, and they are. It is a way to connect the student's world and interests with beginning math skills. You can see the student is expected to participate to accomplish this goal. Student will use math manipulatives to explore, line up, and imitate or attempt to make a sound pattern. It can be easy to get off track here. Remember the lesson objectives. The student is not expected to understand patterns at the end of the lesson. Instead, all of these activities here are meant to engage the student and increase attending and exploration behaviors, as well as provide background knowledge and experience for future lessons. When I look at what we just looked at before, where I had raised my expectations, and this particular set of identified IEP goals, given that the student has been struggling with attention, I'm leaning towards this one, where we're super focused on accomplishing all of the lesson objectives that have to do with engagement and attention. However, it doesn't change what I'm teaching my student. I'm still teaching the same lesson objectives in the same order. The idea is to think about what what can the student accomplish in this time, given the challenges that student has. And there's a third option, and this is to focus on the algebra content area with patterns that are familiar to the student in everyday life. Assuming that the student is starting with the first lesson, in chapter 1, I wrote an IEP goal and objectives from the lessons 1A6, 1A7, 1A8, and 1A9. I combined 2 of the lesson objectives to write 3 IEP objectives. And of course, I will include teaching lessons 1A1 to 1A5, and 1A10 and 1A11 in order to keep that sequence of learning intact. Now, I would think about this one too. This is another possibility. Perhaps, given what the student is interested in, I might think this is a better choice for the student for IEP goals. Perhaps the student would be more successful when the focus is on things that are part of her life. So those are the kinds of decisions I would be making. I have 3 options. I'm pretty much thinking between the second and the third option, though, because it seems to focus on what the student needs most at this moment. Another option for writing IEPs is to consider additional outcomes. These additional outcomes receive less attention typically in IEPs than lesson objectives. They are no less important. However, in the past, we've grown accustomed to seeing math as a collection of individual skills. The additional outcomes are different. They focus more on process and generally can connect to all lesson objectives. You have handouts with all of these alternative goals and objectives. I will walk through them with you with examples from each page. I'm bringing these to your attention to acknowledge that not every student makes gains in the way we expect. And for some students, it's good to know we can measure progress in many different ways. Additional outcomes are skills that can be identified outside of the ordered lesson objectives. The first on the list is actually taken from the lesson objectives and applied to future lessons: attending to math instruction and touching or tolerating touch of math manipulatives. These are atypical lesson objectives that are more behavior-based than math-based. They are pre-readiness skills that can be worked on from lesson to lesson and still apply. Look to lessons in section 1A for others that can be extended beyond the lesson itself. Please note that many of the examples I am showing you in the next set of slides are linked to lesson 1D3. Student will identify sets that are one and many. I chose a specific lesson for clarity, but there are some examples that are more open-ended. Here are some examples of goals and objectives using additional outcomes in lesson 1D3. This set of objectives is written using earlier lesson objectives applied to future lessons. Student will attend to math instruction as demonstrated by eye contact, touching materials, and/or reacting to what is happening during a math lesson. Student will touch or tolerate touch of math tools used in a math lesson as directed by teacher. Establishing supports for completing actions and using language to talk about it is a good example of a collaborative goal with the occupational therapist and speech and language clinician. Using actions that are common within equals lessons, establishing adaptations for these actions is worth considering, as actions are directly tied to cause and effect that is found within math. For example, students who can physically join and separate sets gain an early understanding of the concepts of addition and subtraction, with firsthand experience of recognizing the effects caused by moving a set of objects into 2 separate sets and then joining them back into a whole set. With language, there are links to communication in every activity in the 4-page equals lesson. Often, there is an individual communication system specifically chosen for students who require them. However, some students in the early stages of learning language have fewer message locations that don't include specifics of what is happening during math. In that case, we suggest providing choices using concrete objects as possible. The student speech and language clinician can give specific guidance in how to provide those choices. So it is highly recommended to collaborate on that point and others, so your students are as supported, active, and engaged as possible. Use the Action Dictionary for motor or language support if additional ideas are required. What we're looking for in this set of goals and objectives are alternate supported ways to identify vocabulary and perform or identify an action used with a designated math strategy. For example, student will identify vocabulary word with his/her communication device and when given the word and shown vocabulary card and object representations of word meaning. Student will make a choice from 3 action cards to identify an action performed with lesson materials by the teacher to complete a math strategy. And the third example, student will perform an action with lesson materials using designated support as directed by the teacher. Naming and identifying objects, math tools, and actions is also worth a collaborative effort with the speech and language clinician. As I said earlier, there are multiple opportunities across every equals lesson to talk about math. I have heard many times from teachers and seen in our videos, students are talking more with their devices and verbally when they have equals math vocabulary, action words, and tools loaded into their devices or included in their paper-based communication systems as they engage in a conversation during the lesson and in different settings in the school and at home. We have been astounded to find out when students have access to math language, they use it not only in class, but other classes and at home. We have provided JPEG images for programming students' devices or for paper overlays. These images include vocabulary and action images, vocabulary and action card images, math tools, and objects included as a part of problem solving in the lessons. The vocabulary and action images and card images are in the latest version of Equals members only digital content, and math tool and problem solving images in additional members only content. Both of these can be found here with this link, ablenetinc.com/curriculum-resources. Here are some examples of lesson objectives that focus on making choices within specific lessons and naming objects and sets of one and many, using support specific to the student's mode of communication, communication device, and choice making, in this case, eye gaze. Student will use designated support to indicate one or many in a set as directed by teacher. Student will identify sets of one and many by making a choice when directed by teacher. Student will name the sets of one and many by using communication device independently. Student will name the set with many objects by using eye gaze to choose from 2 sets. Goals and objectives can be written with whole or partial knowledge of the problem-solving process. A goal does not have to include all parts of problem solving. It can be initially written for a student to identify the facts to start off, with pick symbol support or concrete objects to choose from to identify the facts. Other problem-solving steps can be added to the goal in future IEPs. Students can identify the action or actions to solve a problem out of a choice of 2 to 3. They can identify a tool and strategy, make a prediction or estimate, and identify the solution, all with 2 to 3 choices. This is valuable participation that invites students to be active learners in the problem-solving process. Here is a series of objectives during problem solving to demonstrate each step in the process by making choices to determine facts, action, estimate, or prediction, a strategy, and to identify the solution given a set of choices. Student will make a choice from 3 to identify the facts as represented by objects. Student will make a choice from 3 modeled actions paired with an action card to identify an action to use when solving a problem. Student will make a choice from 3 to make an estimate, as represented by sets of one and many objects. Student will make a choice from 3 to choose a strategy, represented by lesson tools and/or materials. Student will make a choice from 3 to identify the solution, represented by objects. A goal related to understanding cause and effect of actions within a math concept gets to the heart of understanding math. Given a specific action or cause, the student identifies the effects of that action. This can happen anywhere in the lesson. I would introduce cause and effect with a basic math concept that clearly shows a cause and effect relationship before applying it to this problem-solving process. Using the lesson, student will identify sets that are one and many. Here are examples of supporting the understanding of cause and effect of the concept of one and many, and later when problem solving. Given 2 sets of equal amounts of one object and additional objects placed with one set the student watches, student will identify the effect by choosing the set with many when directed. Show what happened when I put more cookies here. Did I have one cookie, many cookies, or many blocks? Later, when the student has had more experience with problem solving, cause and effect can be identified within that process. The strategy for this problem is matching the known set of one finger to a set of one on the table, for example, one block, and then compare it to the other set to identify which is one and which is many. There are multiple ways for students to identify the meaning of vocabulary words, actions, and strategies. For example, show the vocabulary word and say it. Show the concrete connection and 1 or 2 others for students to choose. For actions, pair 2 to 3 action cards with demonstrations for student to choose. For strategies, show 2 to 3 tools, actions, and/or lesson materials used in the strategy, again, for the student to choose a strategy. The advantage of showing choices is the flexibility of the type and amount of each decreasing or increasing difficulty to meet student needs. For example, you can show 2 choices, one obviously not correct and one correct. Over time, you can increase choices to 3 and make sure there's at least one choice that is incorrect, yet very close to the correct choice. These lesson objectives focus on identifying vocabulary and actions, as well as perform an action to complete a math strategy. Student will identify vocabulary word, in parentheses, I noted one and many, by choosing from 3 concrete connections representing meaning of 3 words when asked to show what the word means. Student will perform an action to complete a math strategy as directed by the teacher. Student will make a choice from 3 action cards to identify an action performed with lesson materials by the teacher to complete a math strategy to identify one and many. Finally, choices are made continuously in math and in communication, especially in problem solving and when using language during discussion in the lessons. So there are multiple opportunities to engage in choice making throughout the lesson, making it possible for practice all through math class daily. I've given you many examples. The focus of this additional outcome is on choice making itself, if that is a new skill for the student. You can also use common benefits of equals math to identify goals and objectives. The student will increase attention and engagement. The student will increase social interaction. The student will use math vocabulary and action words correctly in math class, other classes, and at home. The student will show an increase in communication. An example would be when questions are modeled during a math lesson, student will respond appropriately using a communication device or object choices. Student will generalize math skills in other subjects and environments. Student will persist in completing a task correctly. Student will self-correct. Student will engage in a productive struggle to find a problem solution. If you are seeing any of these benefits, consider how to measure and increase any of these observed gains. I mentioned collaboration with the occupational therapist and speech and language clinician. I would add your AT specialist, if you have one at your school, as well. Start the conversation with ideas from the Action Dictionary, which can be viewed as a starting point for supporting students' language and its use and actions during math. There is a very strong connection with communication, motor, and understanding, a rich framework that works together to support and enhance learning. Active learners act, observe the result, and talk about it. Equals lessons provide opportunities to do all of that throughout every lesson. It is your creativity and knowledge as a special educator that helps you recognize the need for access and to plan support for each student to a reasonable degree, then follow through in the lessons. However, it also takes time and does not need to be rushed. Students also need time to adjust to using something they have not seen before. It is worth the effort to seek a collaboration to make decisions and make it happen. Working together to write IEP goals and objectives is a very strong first step. As mentioned earlier, JPEG images for vocabulary and action words and cards, math tools, and objects within problem solving in the lessons are found in the latest Equals members only materials and the additional Equals members only materials. You can also capture images from the Equals Tech Lesson Center if you require images not included in those collections. Here is the link again that I showed you earlier, how to locate the latest version of Equals members only materials and the additional Equals members only materials. ablenetinc.com/curriculum-resources. Thank you for attending today's webinar. If you have any questions, contact AbleNet customer service at ablenetinc.com, or call toll-free 1-800-322-0956. They will get you in touch with an Equals staff member who can answer your questions.